Hi everyone, this is Gigi from Kauai Community College. In this video, we will go ahead and talk about the informal definition of infinite limit and how it relates to the vertical asymptote. And then we're going to proceed on a unit on graphing functions. Okay, so what we want to do is tie in limit and graphing functions. Okay, so suppose that f is defined at all points near c, c being this point right here, right? And x is defined within an interval near c. We would say that the limit as x goes to c is infinity if f of x goes really large, right? Arbitrary large, meaning for any number that we think that it is going to cap out at, any number m, then the function is always going to be growing bigger than that number m. So if you say, oh, I think my function is going to be like maybe maxed out at like 100, for example. And then you look at the function value within that interval and it's like 110 or 120, and it's going to keep going above and above any number m that you choose. Then we would say that the limit as x go to c of f of x is infinity. Okay, so what does it mean when you have a limit going to infinity when x is approaching some number c? That tells you that there will be a vertical asymptote right there. So the definition of a vertical asymptote is if the limit as x goes to some number a from the left or from the right. Okay, so from the left or from the right. From the left or from the right of a. If the limit is infinity or negative infinity, if your function is going way up or way down, then there will be a vertical asymptote. Okay, so now the best thing to do right now is to go ahead and take a look at this graph right here. Okay, so as we can see right here, the limit as x goes to 0, x goes to 0, from the left of this function f of x, the limit is going, the function is going way up, so that is infinity, right? So the limit as x goes to 0 from the left of f of x is infinity. Then we would say the line x equal to 0 is a vertical asymptote. Okay, so that's how we apply that definition. And then where else? Well, if you look at it right here, the limit as x goes to 0 from the right of f of x, the function goes to negative infinity. Right here, our function goes down as x goes to 0 from the right. Then we would say x equal to 0 is a vertical asymptote. Okay, where else? Likewise, where else do we have a vertical asymptote here? Right at this moment right here. Okay, so when x is going to 2 from the left and from the right, your function is going way up. So x equal to 2 is also your vertical asymptote. Okay, so we're saying limit at x goes to 2 from the left of f of x is infinity. So we have x equal to 2 is a vertical asymptote. And then we would say what this means is when x is approaching 2 from the left, our function value is going to shoot way up. Okay, so that's kind of tell you what the behavior of the function is, right? Likewise, we would say the limit as x goes to 2 from the right of f of x is positive infinity because when x is approaching 2 from the right, our function goes way up. So we would say, so x equals 2 is a vertical asymptote. Okay, so those are what the definitions of infinite limit is and how that relates to vertical asymptote. Okay, now here is a specific function to look at. So suppose we have the function f of x is equal to 2 minus 5x over x minus 3. Okay, so, and the question is asking us, well, let's just go and study the limit of, the vertical asymptote, right, using the limit definition. So we want to know where that point A might be, okay, because it said if x is approaching A from the left and from the right, well, what's your A? Okay, so what are we after? So we would say that we are after the fact that this function needs to be approaching infinity, right? So when you have a fraction, when does a fraction get really large? When the denominator is small, right? The suspect here would be when the denominator is really small, meaning the denominator is approaching 3, right? Now, the denominator cannot be 3 because that will make the denominator 0 and the function is undefined. However, if x is approaching 3, then the denominator is very small, so that the fraction will be very large. And that is telling us where we are looking at in terms of the suspect for A, right? Now, what are we looking at in terms of limit? We are looking at what is the limit as x goes to 3 from the left of the function 2 minus 5x over x minus 3. And then we are also looking at the limit as x goes to 3 from the right of 2 minus 5x over x minus 3. And if one of those, okay, because it said either one of those, so if one of those limit approaches infinity or negative infinity, then we know that our function is going way up or way down at those points, so that there would be a vertical asymptote. Okay, so let's take a look. When x is approaching 3 from the left, and I'm going to go ahead and take a look here. So here's the x-axis, here's the y-axis, right? And then here's 1, 2, 3. We are looking at, now x is undefined at 3, right? And we're looking at, is there really a vertical asymptote at that point? Well, from when x is approaching 3 from the left, x is a number less than 3. A number less than 3 minus 3 will be a negative small value. Okay? And then a number that is approaching 3, close to 3, and we would say 3 times 5 is 15. 2 minus 15 is going to be roughly negative 13. Negative divided by negative is a positive. 13 divided by a really small value is a really big number. So we are saying when x is approaching 3 from the left, our function is going way up. Therefore, we would say by the definition of vertical asymptote, the line x equal to 3 is a vertical asymptote. Okay, so in terms of studying vertical asymptote, you know x equal to 3 is 1, but it would be nice to know what happened on the right-hand side, right? So let's go ahead and take the limit as x go to 3 from the right. Okay, so in similar reasoning, when x is approaching 3 from the right, you are looking at a number that is a little bit bigger than 3 minus 3, that is going to be a positive small value. And then 3 times 5 is 15. 2 minus 15 is still roughly negative 13 on the numerator. So then negative divided by a positive is a negative. 13 divided by a small value is going to be a very big number. So our function is approaching negative infinity when x is approaching 3 from the right. So we would say, therefore, by the definition of vertical asymptote, x is equal to 3 is a vertical asymptote. And that's the behavior of the function right here when x is approaching 3. Okay, now if we combine with other information that we have learned in terms of the derivative, meaning what is the interval of increasing, decreasing, when does it concave up, when does it concave down, what's the x-intercept, what's the y-intercept, and once you put all of that together, we can actually graph this function. Okay, so that is where we are heading, but in this video, we are only focusing on the vertical asymptote.